Sounds like fun.
Okay, so we are still doing the quadratic formula today, so we don't really have new notes in terms of steps. Quadratic. Okay, but we have some new notes in terms of how things are going to play out. So let's say we have x squared plus 5x plus 7 equals 0. This is, I don't know, bizarre. Case number 1 we need to be aware of. Is this in the correct format to use the quadratic formula?
Yes.
Yes, because we need it to be set equal to 0. Okay, so it is set equal to 0, so then we're going to go through and identify our pieces. So what does A equal?
1.
1. What does B equal?
5.
5. What does C equal?
7.
7. Are we okay on that?
Yep.
Okay, so now we're going to start plugging in. So we'll say negative B. Negative 5. B squared, so 5 squared. Minus 4 times A times C all over 2 times A. Right, this is really what x equals. It's okay if you don't write that x equals until you get to the end, but do understand that that's what we're solving for, right? We are actually solving for that variable in this equation. Okay, so what are we going to do next?
This
Solve the bottom part.
solve.
Okay, so 2 times 1 is 2. What else are we going to do?
Solve under the square.
Underneath the square root. Okay, so either with a calculator or in your head, right? We're doing 5 squared minus 4 times 1 times 7. And what do we get out underneath the square root?
140.
-3.
Negative 3.
Wait.
There's something wrong.
Okay, what are we going to do next?
Square root of negative.
Take the square root of negative 3. What is the square root of negative 3?
It's anonymous.
Whether it is step 1 or step 100, if there is a negative underneath the square root, what do we write? No real solution. Now, here's the dilemma. Writing down no real solution is fine if it's actually a no real solution. However, it is very easy to miss a negative somewhere up here and to get a negative underneath the square root and to think that it is a no real solution. If that is on a test and you are writing down no real solution on 14 problems, do we think that is the correct answer? No. Go back and check. Okay, we're not doing something right. Okay, so while yes, if we get a negative underneath the square root, just like any of the other problems we've looked at, it is a no real solution, that doesn't mean we should be getting it consistently every time. This is my student's favorite because it requires the least amount of work, just like it was with completing the square. They're not all that easy today. How about this one? I want to do it in that order. X squared plus 3x minus 2 equals 0. Is this in the correct format to use the quadratic formula?
Yes.
Yep. What does A equal? 1. What does B equal? 3. What does C equal? Negative 2. Okay, so if we start plugging in, negative B underneath the square root, let's see, b squared, so 3 squared, minus 4 times A times C all over 2 times A. Okay, so what do we get underneath the square root? 17. What do we do next? Square root 17. What is the square root of 17? It is a big long decimal, which means it is an irrational number. Okay, so what do we do with irrational square roots? Simplify them. So we're going to check and see, can we simplify the square root of 17? No.
That was usually
This is my student's next favorite. Right? I can't take the square root of 17, so I can't do anything with it, right? I can't add 3 plus the square root of 17 because these don't have matching radicals. Okay, so there's nothing else I can do with it there. Yes, Yusuf?
What if it's 18 then? And like,
Yeah, that is a good question. What if? That's what we're going to look at next. It's like you read my mind. That's why we're slowly building today. What if we have x squared plus 12x equals 40? Okay, so I know I keep going back to this, but I do just want to continue to reiterate it. Okay? For those of you who look at this problem and are like, why would you not do completing the square? That is fine for you on your test to do completing the square. Right? B is even, all of that, but please understand there will be times that that's not the case. So I don't want you to ignore the fact that you still need to be able to do the quadratic formula. So for right now, even when you see other ways or you think it's easy, let's still practice with the quadratic formula. So is this in the correct form for the quadratic formula?
No.
No, why not?
Because it's
Not equal to 0, so let's make it equal 0. How are we going to do that?
Subtract 40.
Subtract 40, I love it. Okay, so what does A equal?
1.
1. What does B equal? 12. What does C equal?
Negative 40.
Negative 40. Okay, so now we'll plug into the quadratic formula. Tell me what we get under the square root.
Oh, you 3 and 4.
304? Okay, now remember what I said yesterday. Always check and see if it is a perfect square first. Because you do not want to start prime factoring and simplifying 5,625 if it's a perfect square. Okay, so check it first. 304 is not a perfect square. So now we need to simplify it. Okay, so let's start simplifying. What can we split 304 into?
8 and 38.
Oh, that's interesting. I would not have picked that, but okay. Sounds good. I was gonna be like a 2.
Yeah.
That's what I saw too. So then 4 and 2.
Yep.
2 and 2.
And
2 and 19.
2 and 19. 19 is nothing. Okay, so this prime factors into a 2 times 2 times 2 times 2 times 19.
there's 2 sets of 2.
Okay, so we have some pairs. 2, 2. So this becomes a 4 square root 19. Here is the large new piece of today. Right, we should know how to use the quadratic formula. We should know how to get to this 304. We should know how to simplify the square root of 304. Okay, now we need to talk about how to get this in its simplest form. And would we agree that we would never write an answer that has a fraction as something like 3 over 6? All right, what would we turn 3 over 6 into?
1/2.
1/2, right? Because they're both divisible by 3. We sort of have that same idea going on today, but because we have this sort of odd plus or minus in the top, I need to now look at all 3 outside pieces. So I need to look here. I can't just look at 12 and 6, or 12 and 2. I can't just look at 4 and 2. I need to consider all 3 of them. And I'm then going to ask myself, okay, what can I divide them all by? So what are they all divisible by? 2. And if I divide them all by 2, 12 divided by 2 is negative 12 divided by 2 is negative 6. 4 divided by 2 is 2. This square root of 19 is inside the square root, so I never divide it. Outside numbers and inside numbers never get to mix. They are in their own separate worlds. 2 divided by 2 is 1. Would I need to write this as over 1? No, that's optional. Okay, so you could just leave your answer as negative 6 plus or minus 2 square root 19. Are we okay on that? Remember, we also said yesterday that this works no matter where we have A, B, and C. So even though I might choose to solve this a different way than you might choose to solve it, we can still use the quadratic formula on this. Okay, so what does A equal?
4.
What does B equal?
-9.
Negative 7. What does C equal?
0.
I want to show you a difference here. So we plug in. Negative of negative 7, what are we going to say? 7. Plus or minus? This is a problem a lot of the times that students get confused and think it falls in today's category, but it doesn't. Okay, and usually it's because of this mistake right here. We need our C value to equal 0. So if we plug in underneath this square root, what do we get out? 49. Okay, my students often try and make this be a 1 or fill it in with something. Can we take the square root of 49? Yes. So this falls into just like what we did yesterday, where we can calculate both options, because this ends up being a perfect square. No perfect square, prime factor and simplify. Perfect square, take the square root of it and calculate both options. 14 over 8, 7 over 4. Do you see the difference? Okay, so you guys are at a significant disadvantage today.